Are you doing everything right when it comes to health? Eating kale smoothies, sprinkling chia seeds on your breakfast, maybe even hitting the gym regularly, but still noticing that your energy is fading, your strength is slipping, or your muscle tone is just not bouncing back the way it used to. If so, you are not alone, and more importantly, there is an explanation. Today, I want to talk about one of the most underappreciated threats to metabolic health, vitality, and longevity: the gradual wasting of skeletal muscle known as sarcopenia. And I want to focus on a powerful food-based solution. Forget the chia seed trend, because what your body really needs to build muscle, burn fat, and extend health span is far more potent than that. Here's what's really going on inside your body. As we age, and also in the context of poor nutrition, sedentary lifestyle, hormonal shifts, and insulin dysregulation, our skeletal muscle, which is the largest metabolically active tissue in the body, begins to shrink in both size and quality. That loss of muscle mass and strength is sarcopenia. It matters because muscle is not just for appearance, it is a metabolic engine. It drives insulin sensitivity, it regulates blood sugar, it burns calories even at rest, it protects your joints, and it sustains vitality as we get older. When muscle is lost, we don't just lose the six-pack or the athletic look, we lose metabolic resilience. We become more vulnerable to fat gain, to insulin resistance, to fatigue, and to frailty. Research shows up to half of adults over 80 are affected by sarcopenia. Harvard Health Plus One. The good news: sarcopenia is not an inevitable march. It is preventable and even reversible. The key is understanding the root causes, not just treating the symptom of weaker arms or less muscle tone, and addressing them through nutrition, physiology, and lifestyle combined. Today, we will cut through the fads and focus on what the research shows is effective. In this talk, you will learn 6 science-backed insights you can apply immediately, plus a simple but potent food strategy that many people underestimate. I'm going to teach you in clear language, with analogies, physiology, and actionable protocols, why this matters, how your hormones and metabolism are involved, and exactly what to do to build muscle and kill sarcopenia naturally. By the end, you will understand why counting chia seeds or superfoods won't get the job done, what your body truly needs to maintain muscle and metabolic health in your 30s, 40s, 50s, and beyond, how to strategize your nutrition, workouts, hormones, and metabolic contexts so that your muscle becomes a source of strength, energy, and longevity, not a neglected tissue slowly eroding away. And most importantly, what food you should prioritize, when to eat it, how to combine it with movement and hormonal support, so you can apply this starting today. If you are serious about optimizing your energy, your weight, your longevity, not just by chasing calories or macros, but by fixing the root cause of muscle decline, then stay with me, because what I'm about to share will be simple, evidence-based, and deeply practical. Let's dive in. Here is what is really going on inside your body when muscle loss begins. Sarcopenia does not start with weakness in your arms or legs. It begins quietly, deep within your metabolism. Muscle tissue is one of the most energy-demanding organs in the body, second only to the brain. It is constantly exchanging signals with hormones like insulin, cortisol, and growth hormone. When these signals become disrupted, muscle loss accelerates, regardless of how active you are or how much protein you eat. Think of your muscle as the body's most powerful metabolic bank account. Every time you move, eat, or rest, you are making deposits or withdrawals. In your 20s and 30s, your metabolism is highly responsive. The system is efficient. But as the years go by, hormonal balance shifts. Insulin resistance creeps in, cortisol levels rise due to chronic stress, and your muscle becomes less sensitive to growth signals. When that happens, the bank stops growing. The deposits you make through protein and exercise are no longer being efficiently converted into new muscle fibers. The loss of this metabolic sensitivity is known as anabolic resistance. Research shows that older adults often have the same amount of protein intake as younger individuals, but fail to trigger muscle protein synthesis effectively. This resistance is not simply about aging. It is largely driven by inflammation, oxidative stress, and hormonal dysregulation. Let me explain this with a simple analogy. Imagine that your muscle fibers are construction sites and amino acids. The building blocks of protein are your workers. In a healthy, youthful state, the site is well organized. The workers arrive, build efficiently, and repair damage quickly. But when your hormones and metabolism are out of sync, those workers start showing up late. Their tools are dull, and the construction slows down. Over time, your muscle mass starts to deteriorate. What the research shows is that this metabolic slowdown begins decades before visible weakness appears. It starts when your body becomes less efficient at using glucose and fatty acids as fuel, when liver fat increases, and when the balance between insulin and cortisol is disrupted. Once the muscle loses its insulin sensitivity, fat gain accelerates, inflammation rises, and a cycle of catabolism begins. This is why we must stop thinking of sarcopenia as a symptom of aging. It is a symptom of metabolic imbalance. And because muscle controls so many aspects of metabolism, including blood sugar regulation, mitochondrial function, and even cognitive performance, losing it impacts far more than strength. It affects how you burn energy, how you recover, how you sleep, and how you age. So the first truth is this: muscle decline is not a surface problem. It is a signal that the body's most vital energy system is under stress. And once that stress is corrected, the body's natural ability to build muscle, even in later decades, can return. If this breakdown makes sense so far, consider subscribing. I post content like this every day to help you understand your body, your metabolism, and the science behind lasting vitality. Now that we understand that muscle loss begins in the metabolism, let us uncover why so many so-called superfoods fail to protect your muscle, and why chia seeds in particular have been misunderstood in this context. Chia seeds are often promoted as a miracle food, high in omega-3 fatty acids, fiber, and plant protein. They are indeed nutrient-dense, but when it comes to building or preserving muscle, their impact is extremely limited. The reason lies in the biochemistry of amino acids. Your body cannot build new muscle fibers without the full spectrum of essential amino acids, particularly leucine, isoleucine, and valine, the branched-chain amino acids that directly stimulate the molecular pathway known as M2R, or mammalian target of rapamycin. This pathway acts as the biological switch that turns on muscle protein synthesis. Here's the problem. Plant-based proteins, such as those found in chia seeds, flax seeds, or even lentils, contain incomplete amino acid profiles. They are low in leucine, the key amino acid that activates M2R. Without sufficient leucine, the on switch for muscle building never fully flips. The body digests the protein, but it does not translate it into new muscle tissue efficiently. To visualize this, imagine that your muscle is a factory. Protein is the raw material, and leucine is the ignition key that starts the machinery. Chia seeds provide some material, but not the key. You might have a warehouse full of parts, but without ignition, the assembly line never runs. This is why you could be consuming large amounts of plant protein, yet still losing lean mass. Research published in recent years has made this even clearer. Scientists studying muscle metabolism in older adults found that even with adequate total protein, muscle protein synthesis remains low, unless the leucine threshold, around 2 to 3 grams per meal, is met. Foods rich in leucine trigger a much stronger anabolic response, while those low in leucine barely move the needle. This helps explain why so many people who focus on plant-based superfoods struggle to maintain tone and strength as they age. The focus has been misplaced on quantity rather than quality. What the research truly highlights is that muscle health is about the signal, not just the supply. Chia seeds supply nutrients, but they fail to send the strong anabolic signal that your muscle needs to stay active and youthful. When that signal stays silent for years, muscle fibers slowly atrophy, strength declines, balance weakens, and fat begins to infiltrate the muscle tissue, a process known as myosteatosis. This further disrupts insulin sensitivity, creating a loop where the body becomes less efficient at using both protein and energy. The truth is that building muscle requires a specific biological trigger, not just a long list of nutrient claims. Understanding that difference is the foundation of reversing sarcopenia and restoring the body's ability to regenerate lean tissue. If this explanation is making sense so far, stay with me, because in the next section, we will explore the food that actually provides that ignition key, the one that turns muscle growth back on, even in later life. Here is where the real shift begins. The food that builds muscle and helps stop sarcopenia is not a seed, powder, or supplement. It is whole, biologically complete protein, particularly high-quality sources that deliver the full spectrum of essential amino acids, including a robust dose of leucine. Among all options, research consistently points to eggs, especially whole eggs, as one of the most efficient natural triggers of muscle protein synthesis. What makes eggs extraordinary is not just their protein count, but the precise biological ratio of amino acids they contain. The human body recognizes egg protein as a near-perfect match for rebuilding tissue. The yolk provides essential fats, vitamins, and cofactors that enhance absorption, while the white delivers the amino acids that activate the mTOR pathway. Together, they create a complete anabolic environment. Let me explain this with a simple analogy. Imagine your muscle as a construction project. The amino acids from egg protein are not just the bricks. They are also the specialized workers who know exactly how to place each brick correctly. Many plant proteins, by contrast, are like generic materials delivered without instructions. The body can use them, but the process is slower, less efficient, and often incomplete. In several controlled studies on adults of different age groups, whole egg consumption after resistance training produced a significantly higher rate of muscle protein synthesis than egg whites alone. This finding revealed something fascinating. The nutrients in the yolk do more than add calories. They act as biological amplifiers that enhance the muscle building signal. But even beyond the immediate anabolic effects, the benefits of eggs extend deeper into metabolic health. The choline and phospholipids in egg yolk support cell membrane integrity, allowing muscle cells to repair and regenerate more effectively. The vitamin D, found naturally in egg yolks, plays a role in maintaining muscle strength and coordination, and the amino acid leucine within the protein matrix is the key activator of the molecular switch that initiates muscle synthesis. Now, here is what is truly compelling from recent metabolic research. When individuals consume adequate, complete protein, especially from sources like eggs, their insulin sensitivity improves, their resting energy expenditure rises, and their ability to utilize glucose and fat as fuel becomes more efficient. That means muscle growth is not only about gaining strength, it is about restoring the metabolic engine that protects against fat accumulation, fatigue, and premature aging. So while chia seeds may offer fiber and healthy fats, they cannot ignite this process. Muscle health depends on the signaling strength of the food you eat, and foods like eggs deliver the biological precision required to keep those signals clear and powerful. If this perspective on muscle metabolism resonates with you, remember that each concept we discuss builds upon the next in the coming section. We will explore how hormonal balance, especially insulin, cortisol, and growth hormone, determines whether your body stays in a state of repair or decay. Now that we understand what food truly builds muscle, let us look deeper at the hormonal symphony that either accelerates muscle loss or allows muscle to flourish. Sarcopenia does not appear simply because of aging or lack of movement. It is largely orchestrated by shifts in key hormones, insulin, cortisol, and growth hormone, that control the body's anabolic and catabolic balance. Here is what is really going on inside your body. Insulin, often misunderstood as merely a blood sugar hormone, is in fact one of the most powerful anabolic messengers in the body. When insulin functions properly, it helps shuttle amino acids into muscle cells where they are assembled into new protein strands. This process is essential for muscle repair and growth. However, when the body becomes insulin resistant, a state driven by chronic stress, poor sleep, or excess refined carbohydrates, that signal weakens. Instead of delivering nutrients to the muscle, insulin begins to promote fat storage. The muscles are starved even in the midst of abundance. At the same time, cortisol, the body's primary stress hormone, rises in response to ongoing physiological or psychological strain. Cortisol has an essential role in energy regulation, but when levels remain elevated for long periods, it breaks down muscle tissue to release amino acids for fuel. It is the body's survival mechanism. Over time, that continuous breakdown suppresses growth signals and accelerates the very loss we call sarcopenia. Then, there is growth hormone. This hormone acts like the body's internal repair signal, stimulating tissue regeneration, collagen formation, and fat metabolism. It is naturally highest during deep sleep and after intense exertion. Yet in many adults, disrupted sleep patterns and metabolic dysfunction blunt its secretion. Without sufficient growth hormone, the anabolic environment that maintains lean tissue begins to fade. Think of these three hormones, insulin, cortisol, and growth hormone, as the three conductors of your body's metabolic orchestra. When they are in harmony, muscle synthesis and fat metabolism occur naturally. When one instrument falls out of tune, the entire composition changes. Elevated cortisol drowns out the growth hormone's rhythm, while insulin resistance mutes the anabolic notes. The result is a quiet, gradual decline in muscle mass and strength. Scientific evidence continues to affirm this interconnection. Studies examining aging adults show that the most successful preservation of muscle occurs not through isolated nutrient intake, but through the restoration of hormonal sensitivity. When the hormonal environment becomes responsive again, muscle tissue can regenerate even without drastic dietary or physical interventions. This is why it is not enough to simply consume protein or lift weights. Without metabolic harmony, the signals that tell your body to build and repair remain weak. Sarcopenia, in that sense, is not a failure of the muscles themselves, but a reflection of disrupted communication among the body's master regulators. If this makes sense, stay with me, because in the next section, we will uncover an often overlooked connection: how your gut, the invisible ecosystem within you, directly influences your muscle strength, recovery, and resilience. The next layer of understanding muscle health lies not in the muscle itself, but in a system many overlook: the gut. The connection between the gut and the muscle, often called the gut-muscle axis, is one of the most powerful and emerging fields in functional medicine today. What the research shows is that your ability to build, maintain, and repair muscle is deeply influenced by the trillions of microbes living in your intestines. Here is what is really happening inside your body. Every bite of protein you eat must first pass through the digestive tract, where it is broken down into amino acids. These amino acids are then absorbed through the intestinal wall and delivered into the bloodstream. But if the gut lining is inflamed or the microbiome is imbalanced, that process becomes inefficient. Instead of absorbing the full spectrum of amino acids, your body may only take in fragments, meaning less fuel reaches your muscle cells. Let me explain this with a simple analogy. Imagine your gut as a customs gate. Every nutrient, vitamin, and amino acid must pass inspection before entering your internal economy. When the gate functions well, everything flows smoothly and efficiently. But when the gate is damaged or overwhelmed by toxins, stress, or poor diet, the system becomes sluggish. Valuable materials are lost, and what gets through may trigger immune reactions rather than growth. Research has shown that individuals with a diverse and balanced microbiome tend to maintain stronger muscles as they age. Certain beneficial bacteria, particularly those that produce short-chain fatty acids such as butyrate, play a key role in reducing inflammation and improving nutrient absorption. Butyrate also acts as a signaling molecule, supporting the mitochondrial function within muscle cells and enhancing their ability to generate energy. On the other hand, when the gut microbiome shifts toward imbalance, a condition known as dysbiosis, inflammatory compounds leak into the bloodstream. These compounds interfere with insulin sensitivity, suppress growth hormone activity, and impair muscle protein synthesis. The result is a state of silent metabolic stress that gradually erodes muscle mass over time. This is why muscle health cannot be separated from digestive health. The two are linked in a continuous feedback loop. A healthy gut supports strong muscles, and active muscle tissue, in turn, sends beneficial anti-inflammatory signals back to the gut. When either side weakens, the entire system suffers. It is remarkable to think that something as small as a microscopic imbalance in the intestines can influence something as visible as the strength of your legs or arms. Yet, that is exactly what the science now confirms. Your gut is not just digesting food, it is dictating how efficiently your body can use that food to preserve youth, vitality, and resilience. If this deeper look into the gut muscle axis resonates with you, stay with me. In the next section, we will bring all of these insights together, showing how your nutrition, hormones, and metabolism align into a unified system that determines not just how strong you are, but how long that strength lasts. At this point, we can begin to see how every system in the body is interconnected. Muscle, hormones, metabolism, and even the gut. They operate like a network of communication lines, and when one signal weakens, the others follow. Sarcopenia, therefore, is not simply the fading of strength. It is the fading of biological communication. And when that communication is restored, the body begins to repair itself naturally. Here is what is really going on inside your body when this repair process begins. As complete amino acids enter the bloodstream, they activate molecular pathways that tell the muscle to build, not break down. These pathways work in harmony with insulin, growth hormone, and mitochondrial activity. The mitochondria, the power generators inside your cells, increase their capacity to produce energy. This energy then fuels repair, regeneration, and the creation of new muscle fibers. Think of it as a symphony. The amino acids are the instruments, the hormones are the conductors, and the mitochondria are the acoustics of the hall itself. When all three are tuned and aligned, the result is harmony, energy, strength, and vitality. But when one element falls out of rhythm, the sound becomes distorted. That distortion is what we experience as fatigue, muscle loss, and weakness. Studies over the last decade have confirmed that individuals who maintain strong mitochondrial function not only preserve muscle mass, but also maintain sharper cognitive function, better metabolic flexibility, and longer health spans. This is because healthy muscle acts as a reservoir of metabolic stability. It soaks up excess glucose, burns fat efficiently, and stabilizes hormonal rhythms. In essence, muscle is a longevity organ. When viewed through this lens, it becomes clear that reversing sarcopenia is not a cosmetic or athletic goal. It is a survival mechanism. Maintaining muscle mass protects every other organ system from decline. It supports immune resilience, enhances circulation, and even modulates inflammation throughout the body. There's another remarkable layer to this relationship. Strong, active muscle fibers release molecules called myokines, which act like internal messengers. These myokines travel through the bloodstream and communicate with the liver, brain, and fat tissue, telling them to stay metabolically active and youthful. They can even help suppress the low-grade inflammation that contributes to aging itself. So, when you strengthen your muscle, you are not just improving your physical form, you are changing your body's internal chemistry toward regeneration. This understanding brings us to an important truth. Longevity is not built in years, it is built in muscle. The more metabolically active your muscle tissue remains, the longer every cell in your body functions as it should. Sarcopenia, therefore, is not just the loss of strength, it is the loss of biological time. If this broader view of muscle as a central organ of longevity makes sense to you, stay with me. In the conclusion, we will bring together everything we have explored, the science, the root causes, and the biological connections to show how protecting muscle is the key to protecting life itself. We began this journey with a simple idea that muscle loss is not an inevitable part of aging, but a reflection of deeper metabolic imbalance. Along the way, we have uncovered the truth behind that statement. Muscle is not just tissue. It is a living, breathing organ that governs energy, longevity, and vitality. When it thrives, every system in the body benefits. When it declines, the entire network begins to weaken. Here's what is really going on inside your body when you preserve or rebuild muscle. You're not just improving strength or endurance. You are recalibrating the body's internal chemistry. The The liver becomes more efficient at processing energy. Insulin becomes more sensitive. Cortisol levels normalize, and the mitochondria regain their rhythm. This chain reaction restores balance across the entire metabolic landscape. Throughout this discussion, we have seen how the problem of sarcopenia is rooted not in aging itself, but in the disruption of signals, hormonal, nutritional, and cellular. We learned that foods like chia seeds, while healthy, do not provide the biological message required for growth. Instead, complete protein sources, such as whole eggs, deliver the full array of amino acids that awaken the body's natural anabolic machinery. We also explored how the gut and microbiome form the foundation for nutrient absorption and systemic harmony, influencing everything from inflammation to mitochondrial function. What emerges from all of this is a new understanding of muscle health, one that views it not as an isolated goal, but as the cornerstone of metabolic resilience. Building and preserving muscle is, in fact, one of the most powerful forms of disease prevention. It protects the heart, the brain, and the immune system. It supports mobility, balance, and independence. And most importantly, it slows the biological clock. Let me explain this with one final analogy. Imagine your body as a city powered by countless generators. Each muscle fiber is one of those generators. When they are strong, the lights of the city burn bright. Metabolism runs smoothly, energy is abundant,